Welcome back to Go Figure School of Mathematics. Today is Lesson 4 of Algebra 1, Arithmetic as a Foundation. So far, we've built fractions, shapes, and measuring. Today, we lay the foundation under all of algebra, the number system itself. We'll organize what a number really is, place every number on a single line, sharpen our fraction skills to include multiplying and dividing, and learn a powerful tool for converting measurements called the unit multiplier. This lesson has many parts, but they all connect. Let's take them one careful step at a time. First, what we already know. Subtract 5/6 minus 1/3. What's the common denominator that we need? 6. So let's change our fractions. The first one stays the same, 5/6 minus 2/3, then minus 2/6, and then we can subtract to get 3/6, which simplifies to 1/2. Second, you have a circle with a diameter of 8 centimeters. Find its exact circumference. So, which formula do we use for circumference, and which part do we need to keep exactly? So our formula is circumference equals pi times diameter, and the thing that we need to keep exact is pi. So we just replace 8 for diameter and leave pi. So our circumference is 8 pi, and we use our units, centimeters. All right, we have a quadrilateral with exactly one pair of parallel sides. And we know that quadrilateral means four-sided polygon. So one pair of parallel sides is a trapezoid. All right, today, numbers, numerals, and digits. So first, a careful distinction. A number is an idea of a quantity, how many, like the amount of fingers on your hand. A numeral is the symbol we use to write for that idea, like the mark 5. The number is the thought, the numeral is the writing. The natural numbers, or also called the counting numbers, are 1, 2, 3, 4, and so on. And digits are the 10 symbols that we use, 0 through 9, in our base 10 decimal system. The position of each digit in a number tells its value. If we take the counting numbers and add 0, add the negatives, and fill in every fraction and every non-repeating decimal in between, we get the real numbers. Every number that can be located on a number line. So positive numbers are any numbers that are greater than 0 or to the right of 0 on a number line. And negative numbers are those that are less than 0 to the left of 0. And 0 is not positive, it's not negative, but it is real. And also, when we have a numeral written with no sign in front of it, like 7, it's understood to be positive. Whereas if you had a minus sign in front of the 7, minus 7, that would be negative. Okay, so we want to build a number line. So the first thing we do is draw a line, a horizontal line with arrowheads to show that it goes on forever in both ways. So there's our horizontal line, and there's our arrows. And then we want to mark a position for the origin, which is 0. And then we want to space equal ticks to the right for positive numbers and to the left for negative numbers. So here we could have 1, 2, 3, 4, and so on. And to the left of 0, we have -1, -2, -3, -4, and so on. And to graph a number, we just put a solid dot on its tick mark. So, for example, we want to graph the numbers -3, 0, and 2. So here's our number line. We can start with 0 as our origin right there. And then for -3, we count 3 spots over to the left for -3. And for 2, we count 2 spots over to the right from 0 to get 2. So which is farther to the left on the line, -3 or 2? Right, -3. It's to the left, so it's the smaller number. On a number line, the farther left always means smaller. All right, multiplying fractions. So this formula might look a little complicated, but multiplying fractions is beautifully direct. All we need to do is multiply the numerators and then multiply the denominators. So, for example, 2/3 times 4/5. Let me just write this out. 2/3 times 4/5. We just multiply our numerators equals 8 and multiply our denominators 15. 8/15. But there is a smarter way to multiply fractions, and that is canceling common factors before multiplying. So I'm going to rewrite this problem, 3/4 times 8/9. So if we find common factors between the numerator and the denominator, we want to take those out. So between 3 and 9, a common factor is 3. So we can divide this 3 by 3 to get 1. We can divide the 9 by 3 to get 3. So we just reduced that fraction, we canceled. Then we can see that between 4 and 8, we have a common factor of 4. So I can cancel that 4 and turn it into 1. I can cancel the 8 and turn it into 2. Then we have much smaller numbers to work with when we multiply. So 1 times 2, 2, and 1 times 3 is 3. So that fraction is 2/3. And it is far easier to cancel your common factors before multiplying them than to multiply big numbers and reduce afterwards. So always look for shared factors between any numerator and any denominator first. Dividing fractions, we want to flip and multiply. So to divide, we want to multiply by the reciprocal. The second fraction must be flipped. So here's an example. We have 2/3 divided by 4/5. What we want to do is change that to multiplication and flip the second fraction. So it becomes 2/3 times 5/4. And then we multiply like we just learned. So we get 10/12 here, and that reduces to 5/6. Now, do you notice how we could have canceled first? So notice how we could have factored out a 2 here, and that would have been 1. This turns into 2. And then between 3 and 5, there's no factoring or cancellation that we can do. So now we have 1 times 5, which is 5, and 3 times 2, which is 6. So canceling first just got us directly to a smaller fraction. The next one, what is 1/2 divided by 1/4? So what we need to do is take our 1/2 and change the division to multiplication and flip that second fraction. And now we're multiplying to get 4/2, which reduces to 2. And again, we could have canceled here. We could have factored out a 2 from these and gotten our answer the same, 2/1, which is 2. And notice that the answer, 2, is bigger than 1/2 because we asked how many fourths are fit into 1/2. And just remember to flip the second fraction, never the first one, and never divide straight across. Comparing and the basic properties. So the symbols of equality and inequality. Equals sign means the two sides are the same value. The not equals has a slash through it. For inequalities, the open end of the symbol faces the larger number. Less than points to the smaller side, greater than opens toward the larger. We also have less than or equal and greater than or equal to, which allow the two sides to be equal as well. The symbol opens toward the larger number. So here we're comparing 3/4 and 2/3. Well, first, the best way to compare them is to have common denominators. So the common denominator here is 12, and we can change those fractions to 9/12 and compare it to 8/12. Since 9/12 is greater than 8/12, that means 3/4 is greater than 2/3. And some properties of the basic operations. There's 3 quiet but important rules. So adding 0 to any number leaves it unchanged. 0 is the identity for addition. Multiplying any number by 1 leaves it unchanged because 1 is the identity for multiplication. And multiplying any number by 0 always gives 0. And of course, there's vocabulary with every operation. In addition, the numbers we add are add-ins, and the result is the sum. In subtraction, the minuend minus the subtrahend equals the difference. In multiplication, the factors multiply to a product. In division, the dividend is divided by the divisor, which equals the quotient. And in fractions, our top number is our numerator and our bottom number is our denominator. So in the sentence, 8 minus 3 equals 5. Which number is the minuend and which is the difference? Right, 8 is the minuend and 5 is the difference. All right, operations with decimal numbers. So when we're adding or subtracting decimals, we want to line up our points. So let's rewrite this in vertical format just to see what it looks like. We are making sure that our decimal points are lined up so that our digits are in the proper place. And then we can go ahead and add. So 5 plus 0. And then our decimal point is in line with the other ones that we had. And there we have our answer. When we're multiplying with decimals, we just need to count the total decimal places. So again, let's write this in vertical format. 1.2 times 0.3. Then we just multiply as if there weren't any decimals there. And then we count how many digits do we have behind decimal points in our factors. We have 1 here and 2 here. So then in our answer, we need 2 digits behind our decimal point. And we can always put a 0 in the ones place when there isn't anything there. Now, when we divide with decimals, we want to make our divisor a whole number first. So in order to do that, we can multiply these numbers by 10 as many times as we need. In this case, we just need to multiply it by 10 once. So the 4.8 turns into 48 and 6/10 turns into 6, and then we can just divide. I'll also show what that looks like in long division. We want to move our decimal point over and also move our decimal point the same amount of spaces in our dividend, and then we can divide. 48 divided by 6 equals 8. Next, we have unit multipliers. So a unit multiplier is a fraction that is equal to 1 that changes the units. So, for example, we have 12 inches and 1 foot. So both unit multipliers, we have 12 inches per 1 foot or 1 foot per 12 inches. They both equal 1 because they represent the same distance. So to convert 5 feet to inches, we multiply the unit multiplier that cancels feet. We want feet on the bottom to cancel the feet we start with. So I'm going to write this a little bit differently so we can see it better. 5 feet is what we're starting with, and we're converting it to inches. So the unit multiplier I'm going to use is 1 foot in the denominator so that our feet will cancel. 1 foot is equal to 12 inches. So you can see that the feet cancel out and we're left with a unit of inches, which is exactly what we wanted. So now we have 5 times 12, which is 60 inches. And that's just over 1, which reduces to 60 inches. And remember to choose the correct unit multiplier. We want to pick the one whose fraction puts the unit you want to cancel in the opposite position. The top cancels the bottom. The unit you keep should be the one that does not cancel. Tables of equivalent length. So in the US customary system, we have 12 inches is equivalent to 1 foot, 3 feet is equal to 1 yard, 5,280 feet are in a mile, or 1,760 yards are in a mile. Then with the metric system, we have 10 millimeters equaling 1 centimeter, 100 centimeters equals 1 meter, 1,000 meters is 1 kilometer, and 1,000 millimeters equals 1 meter. So this might be a good screen to screenshot, just memorize, because you will need to use these conversions in your problems. So sometimes we'll use 1 unit multiplier and sometimes we might need 2. So in this case, we're converting 250 centimeters to meters. So we have 250 centimeters and the unit multiplier we use is 1 meter per 100 centimeters. Those centimeters will cancel out and then we're just left with 250 over 100 to get 2.5 meters. And here's a case where we need 2 multipliers. So we're converting yards, 3 yards to inches. So again, I'm going to write this a little bit differently so you can see how the units cancel out. So 3 yards. And the unit multiplier we're going to use is 3 feet for 1 yard. But we still need to get it down to inches. So there are 12 inches in 1 foot. So you can see our yards will cancel out, our feet cancel out, then we're left with 3 times 12, which equals 108, and then our units that we're left with is inches. So 3 yards equals 108 inches. All right, here are some problems to try together. So why don't you try this first and then check back to see if we got the same answer. Okay, so this is division with fractions. So what do we do instead of dividing across? What do we need to do? Flip the divisor and then multiply. So we're going to rewrite this as 7/9 multiplied by flipping the divisor 3/2. Now, we could just multiply across now, but there is a simpler way. We can factor out a 3. So let's factor out a 3 from here and here. There's no more factoring that we can do, so now we'll multiply 7 times 1 and 3 times 2. So we get 7/6. And it's fine if you want to leave it in this form. You could also rename this to a mixed number, 1 and 1/6. Okay. Okay, this problem we just did, so let's make up a new one. Let's convert 4.5 meters to centimeters. We'll cross out that. So here we're going to rewrite 4.5 meters. We're going to multiply it by a unit multiplier. We want to cancel out our meters and keep centimeters. So we have 100 centimeters in 1 meter. Those meters cancel. And now we have 4.5 times 100, which equals 450, and our units are centimeters. Now you're ready to practice on your own. Remember, mathematics improves through careful practice. Cancel before you multiply, flip before you divide, and for every conversion, ask which unit needs to cancel. In today's worksheet, you'll see problems of graphing numbers on a number line, dividing fractions, subtracting fractions, that's a review, comparing fractions with greater than, less than, or equal to, multiplying fractions, and conversion problems. So where does this arithmetic show up in everyday life? See if you can think of something and put it in the comments, and then see if we came up with any of the same ideas. All right, so some real world places that I came up with are recipe scaling. So doubling or having a recipe means multiplying every fractional ingredient amount. In money and decimals, prices, discounts, and totals are decimal arithmetic, adding, multiplying, and dividing decimals the way we did with some of our examples. And then for unit conversion, maybe you want to convert your height from inches to feet. Today we laid the foundation. A number is an idea and a numeral is its symbol. The real numbers all live on one number line, where positives go right and negatives go left, and 0, real but not positive, sits in the middle. We learned to multiply fractions by canceling first, and to divide by multiplying by the reciprocal. We named the parts of every operation, reviewed decimals, and learned the unit multiplier, choosing the one that cancels the unit we want to remove. In our next lesson, these tools become the grammar of algebra. Complete your practice with care and go figure.